Okay, Dr. J here again. You know, I just can't help myself with these diagrams and whatever when it comes to the heart. So this is another little quick little video to fill in some of the gaps. You don't need to know this for the exam. You may see something like this diagram. It's used all over the place when it comes to cardiovascular physiology. I had it included in the PowerPoint because I really like it. But as I said before, you know, we just don't have a lot of time to get to things in lecture. So this is just extra. But if you're interested, this is kind of really cool to look at. Okay, so we are going to focus on, I had to think for a second here. What I want to do is I want to focus on, we're going to start with systole here. And these things down here, folks, are referring to the ventricles. So here we see ventricular systole. And this is going to be ventricular diastole. Over here's the start of the next one. We really don't need that. We're going to just focus on one complete cycle. But this is cool because it shows you it again. So we're just going to focus from here over, right? It just repeats itself if you're interested. It outlays what's happening with the EKG at the same time as the pressure relationships. All right, folks, that's why this is so useful, you know, once you get into it for those who want to. Ha, ha, ha. By the way, it also has the heart sounds, the phonocardiogram. These are the heart sounds, the lub-dub. So we see the heart sounds 1, 2, because there's actually 4. Yes, yes, yes. These are the heart sounds. So it really puts a lot of things together. But we're going to focus on the pressure. This blue line, you see this blue thing going up? That's what we're focusing on. So I'm going to erase this, but this is ventricular pressure. Didn't we say that blood moves through the heart along a pressure gradient? Well, of course it does. So this is going to just show us that pressure gradient. Now, before we get to ventricular systole, this is going to, in our parlance, this was phase number 2 of the cardiac cycle, and this is phase number 3 of the cardiac cycle. What was our phase number 1? Well, atrial systole. So what's happening before here is atrial systole, okay? During atrial systole, maybe I'll go back to green just because it'll be a different color. During atrial systole, what was happening? The atrial walls contract, and the atrial volume goes down, but the atrial pressure goes up. We develop a pressure gradient to push blood from the atria into the ventricles. But what I want to point out is during atrial systole, that atrial pressure, the atrial pressure is low. I mean high, excuse me. See, even gets me. The atrial pressure is high. And then what is that ventricular pressure? Which is what we're following in the blue. Ventricular pressure is low. And that's what they're showing us here. This ventricular pressure is very low, in fact. It's 0, right? But as we move into phase 2, ventricular systole, it had 2 parts, okay? So ventricular systole as a whole, let me go back to red here. Ventricular systole as a whole goes from here to here. So this is ventricular systole. But the dotted line is showing us the period of isovolumetric contraction. So this part is isovolumetric contraction. And the remaining is ventricular ejection. Didn't we break ventricular systole down into 2 parts? Yes, we did. So when we have ventricular systole, what's happening? We're going to begin to lower the volume of the ventricles. When we lower the volume of the ventricles, let me use blue. When we lower the volume of the ventricles, what happens to the pressure? So now the pressure goes up. And I just want to point out how much it goes up. Look at how high this blue thing goes, way up. Sharp rise in pressure, and that's what this is showing you. The first period of this, from here to here, is just isovolumetric. The other thing that this graph shows you is when the valves open. So right here, when we move from isovolumetric into ejection, that's when the semilunar valves open. And then we get to ventricular diastole. For ventricular diastole, that starts here, and it's going to end here, right? Ventricular in blue, ventricular diastole. Well, didn't we say the first period of ventricular diastole, here it's going to be blue, was isovolumetric relaxation. So there's a period where we increase the volume of the ventricles, which lowers the pressure. So now our ventricular pressure goes down. At first, there's no movement of blood, but then there's so much movement of blood, there's so much of an increase in volume and a drop in pressure that the pressure in the ventricles drops below the pressure in the atria. And look, now the AV valves open to lead to early filling. So only from here to here is our isovolumetric relaxation. From here all the way over, actually, I think I ended this a little early. Late, I mean. It's going to end right here. My apologies. It's going to end right there. Right. See here? So it's going to end here. So from here to here is early filling. All right, so it's just a way to show us the relationship of how much that pressure changes and what it leads to.